city first quantum computer going to be present? Is there anyone who has idea on this? Anybody who is aware of the news? Okay, Vimal, you're aware. Fine. Cool. So we'll start with very basic. Okay. So the first thing that comes to your mind when we talk about computer is that computers deal with two bits. Okay. And those are zeros and one, right? Is everyone aware of this? I hope so. Each and every person present here knows that normally computers, the computers that we use basically, they are based upon bits, and there are two kinds of bits, zero and one, binary. Correct. Correct, Naman. Correct, Bhava. So can you all quickly react with thumbs up if you're able to understand till here, you're clear with this concept. So all the text that you type in while you're having conversations on phone, or all the or audios that you listen, all the videos that you see in your mobile phones or your laptops, they are all converted into zero and one, and that is how they are being played. So you see them in a different format, but background they are all just combination of zeros and ones. But when we talk about quantum computers, what do we talk about? There are possibilities. There are certain possibilities before final answer, and we'll understand what do I mean by this in a while. Okay, I'll explain you this. So quantum computers, we don't say that it is either zero or one. We say that it can coexist both at the same time. And what do I mean by this is what I'll cover soon. So just, wait on. I know you must have a lot of curiosity by now. But then, given that we already have computers and we have laptops, we earlier it was like supercomputers, then we had mainframe computers, then we have like these laptops, desktops, PCs, and now our mobile phone also offers a lot of computing options, right? So the mobile phone itself, the phone that you possess, it has got good processing power, it has got good RAM, everything. And the question is that why do we even need computer now? Why a new kind of a computer? Is there any problem that cannot be solved by the existing computers? That is why we need this new kind of computer. Why are we even talking about them? So the answer is yes. So there are a lot of problems that your classical computers, the computers that we use right now, the devices that we use right now, yes, time. It can be solved, but it will take time. Very good, Atanu, very good, Vimal, Shubham, Ankit, great. So there, all these problems that I'll be telling you, they are all solvable with our classical computers, the devices that we have right now. But then the amount of time required to solve these problems are like in years. So there is no, the time constraint is there. We want everything to be solved, quickly. So one example that I can give you here is, let's say that imagine there are three cities. There is C1, there is C2, there is C3. Okay, there is one city where then you live in, and there are two cities which you want to travel. Now, given the road infrastructure of our country, we have multiple paths between these cities, right? We'll have multiple roads to travel from one city to another. But if I'm to ask you that, let's say you want to cover all these three cities, but you want to do it in the minimum amount of time, and you should, take in minimum distance. You should travel minimum distance. Will you be able to find it out? You need to travel between three cities, and then you need to do it in minimum amount of time. सबसे कम time लगे and सबसे छोटा रास्ता हो. That is what you need to do. Yes. So what do you need to do initially? You need to explore all the possible paths. सारे रास्ते जो भी हैं travel करने के लिए, you will find them out. You will make a list of it, and then you'll figure out, okay, this is the smallest route. This is just this number of kilometers, and this is what I should take. Yes, this is solvable if I talk about three cities, right? Now imagine instead of three, I'm saying 50 cities. You decide to go on a tour for some few months, and you decide to cover 50 cities. Can you imagine number of possibilities that we'll have in that case? There will be endless number of roads. There will be endless options that you need to explore. And if you have to do that choosing these computers, it is going to be very much time taking. This is not a solvable problem that it will be solved initially. Are you able to understand this thing? Everyone, can I get a quick thumbs up reaction from all of you if everything is clear till now? Great. So I expect you all to respond in chats or react with thumbs up, whatever is comfortable for you, okay? And if you're unable to understand, then also please speak up, please ask questions in chat. I'll be happy to answer them. Great. So this problem that I told you, it has got a formal name. It is called as traveling salesman problem. But again, I don't want to introduce you to the technical terminologies right now. Just understand the concept that why do we even need a new kind of computer? So basically, the question is, you know that lot of logistics uh, travel happens through trucks in India. बहुत सारा सामान है जो बाय रोड ट्रैवल एक्सपोर्ट होता है इंपोर्ट होता है ट्रक्स के थ्रू. During night, you would see all the trucks running on the road. So we need to optimize traffic as well for citizens. We need to optimize logistics so that we are able to get resources at the right time. Got it? So this is one such problem, and here I have mentioned it, optimizing traffic and logistics. So this is the problem that I explained to you. Then there are certain more problems as well. So designing new medicines. Again, you all have studied chemistry in class 12th. I'll explain you this in brief detail. But the thing is, we need to design new medicines. And designing new medicines, we need to research on the chemical compounds, chemical formulas. We need to find certain combinations of it. And it takes in a lot of time. Then we have creating better batteries. So nowadays we talk about EVs. EVs के बारे में सुना है सबने, right? We talk about EVs. We are talking about electric vehicles, and we need better batteries. We need to do more research around it. We need to have better you know uh, devices there. So that is one such reason. Then there is something called as cyber security. Cyber security is one of the active fields that you'll study. Okay, there is something called a cyber security. Everyone is aware about it. So all of you, those who use online transactions, किसी ने अगर online banking use किया, even if you log into some platform, you have your login ID and password, right? And that password is stored somewhere. That password is a secret, message. So let's say when you're having conversation with your friend, कभी कभी आप कुछ secret words use करते हो जो सिर्फ आपको and आपके friend को पता होता है. Nobody else knows that, right? So that is how even passwords, these passwords are stored in some secret message format. So अगर आपका message है hello, मान लो it is H. So H is not stored as H. उसको कुछ और character में लिखा जाता है. So maybe it is represented as E. So this is called as cryptography. आप बाद में पढ़ोगे उसको भी. How are the passwords stored, and what do we understand by securing all these things. Please don't do this kiddish things. You guys are mature. So now these are the 4 key use cases here. Creating better batteries, designing new medicines, then designing cybersecurity systems. So I'll tell you that what problem can happen if quantum computers, they are currently not that good. If they are good enough, we'll have something called as quantum cryptography field is there, and then we'll be able to. There is some encryption. जो भी हम पासवर्ड्स को सीक्रेट फॉर्म में कन्वर्ट करते हैं उस प्रोसेस को बोलते हैं encryption. So encryptions can be decoded. वो कैसे convert हुआ है? Let's say you and your friend are having some secret conversation and somebody else hears it. Then that person is a hacker, that he is hearing your conversation. Similarly, quantum systems are capable of breaking all these encryptions. So we need better cryptography, better cybersecurity systems as well. So this is why we needed new kind of a computer, and that is why we talked about quantum computer. Now, as I told you, classical computer, they're just combination of zeros and ones. Zero or one, you can compare it with a switch board, switch button. Let's say if I turn on a fan, turn off a fan. So if I'm turning off the fan, then it's basically off or zero. If I'm talking about quantum computers, we talk about qubits. So qubits are basically Am I audible to you? Okay, there is some lag happening. Fine. Well, I'll speak slowly. Okay, till here is everything clear? Okay. So if there's anything as such, just inform me. I'll speak slowly so that you're able to follow along with me. Cool. So as I told you, classical computers, we talk about bits. You can compare it with switching on and off your fans, and then text, images, audio, video, anything that you deal with in terms of data is all converted to zeros and ones. Now in quantum computers, we talk about qubit. Okay. In classical, we have bits. In quantum, we have qubit. How many of you have heard of the term qubit? Can you please answer me in chat? And those who are hearing it for the first time, please let me know that you are hearing it for the first time. Just type in first time. Okay. Quite a few of you have heard of it already. Now you see an image here, but again, you don't need to understand this. I'll come to this later. I'll tell you what qubit is. So similar to how we have bits in classical computers, we have qubits in quantum computers. Now, what you need to understand is in classical computers, we have either 0 or 1. But if I talk about qubit is just possibilities of zeros and ones. It's, various possibilities, combinations of zeros and ones. So that is why you see here it is written as combination of 0 and 1. So again, I'll explain you it with an example. So let's say it's a very simple example. In fact, those who have had interviews with me might remember this. I always use this to explain. So let's say if I'm tossing a coin, there's some match happening, and then there are two teams, and we need to toss a coin. So either of the team chooses heads or tails, right? And when the umpire tosses the coin, you either get heads or you either get tails. So you can compare head, let's say head is 0 and tails is 1. So 0 or 1. Is everyone clear with this? Now, this is how classical computers function. If I'm spinning the coin, if the coin is spinning on the table, both heads and tails coexist at the same time. Can you tell me how much percentage of heads and how much percentage of tails? Or can you tell me whether it is heads or tails when the coin is spinning? Anybody? No, you cannot say it, right? So there can be 50-50 chances, there can be 40-50 chances, there can be 60-40 chances, anything as such, right? So this is basically quantum computers or qubits. So in qubits, there are some possibilities. So combination. So it is uncertain, right? Raghav, great. Combination of ones and zeros. So there is basically uncertainty. There are multiple possibilities, and that is what you see here in the equation. So let me come back here. Now this is called as bracket notation. Here that you see, this is how qubits are represented. So a bit can either be 0 or 1. A qubit bit is either 0. 0 is represented here, 1 is represented here. Whereas qubit can have both zeros and ones. So this is dirac notation. Again, I would not go into technical details here. You will study this in future. So here you see two things, alpha and beta. Alpha beta दिखता है सबको? Alpha beta आप लोग को पता भी होगा. So you can compare alpha and beta with the probabilities. Let's say if it is 50% of 0 and 50% of 1. This is kit 0 and kit 1. Okay, so this is how alpha can be 40, beta can be 60, something like this. That is how you can compare. This is just for understanding. This is not the exact, technical definition of it. Just to make you guys understand the concept, I've used some analogy. Okay, again, I'm repeating that. So if I'm to summarize, classical bits are zeros and one, qubits are possibilities of zeros and one. Yes, qubits and bytes differ. Psi sign, this is the way like we denote the qubit by psi. Okay. This is the equation. Psi, contains combination possibilities of zeros and ones. So it is kit 0, kit 1 with alpha, beta as some certain possibilities. And then, like just to understand, you can compare classical bit with a light switch. You can compare qubit with a spinning coins. Qubit are just applicable for quantum computers. Classical bits are applicable for all sorts of devices that you're using till now. Okay. Is this clear to everyone till here? Any doubts till here? Cool. I'll move forward then. Okay. So this we have covered. No, we cannot represent qubits in terms of bytes, Raghav. That is not possible. They are two different computers. They are two different systems, so you cannot compare them likewise. In fact, quantum. Before I even talk about quantum computers, the thing is quantum physics, quantum mechanics. Quantum physics is you have already studied till class 12th. Can you tell me what do we understand by quantum physics? What particles do we talk about in quantum physics? जिसका भी physics अच्छा है, photons, yes. So you've already studied. So it is not a new idea. Quantum physics, quantum mechanics, they existed back in 1900s. But then quantum computing is something that we, are having a lot of new things. Is that fine? So, quantum mechanics is what you already deal with. Quantum physics is talking about small particles. You must have studied electrons, photons, neutrons. आप लोगों ने Heisenberg uncertainty principle पढ़ा होगा. You would have studied Schrodinger's wave equation. Just tell me if you remember this or not. Yes? Schrodinger's wave equation, Heisenberg uncertainty principle, wave particle duality experiment, Young's double slit experiment. Yes, atomic structure आप लोग ने chemistry में पढ़ा है. So all these are the concepts that quantum computing is based upon. It is all physics and mathematics behind the scenes that you see, and then we are clubbing it with computing systems. So it is not something new that you already don't know. uh, all the LED lights, they are based upon quantum physics. The laser pointers that we have, they are based upon quantum physics concepts. Smartphones, they use chips. There are certain chips within our smartphones. So they are also based upon quantum mechanics and quantum physics. We have solar panels. Solar panels are based upon quantum physics. MRI scanner devices are there in hospitals. And then electron microscopes, maybe you would have done some experiment with the microscopes as well in your labs. Right. So again, they are all based upon we observe small minute particles. They are all based upon quantum physics. Is everyone able to understand that this already coexists? It is not something new, but then talking about quantum computing is what we are having research in the ongoing field. Quantum mechanics, quantum physics was from the time of Einstein. Then one name that you need to remember is, I'll tell that. So there is Richard Feynman. So Richard Feynman is what you need to remember. He is, called as, he's done great experiments. And a lot of lectures of his also present on YouTube, and his material is great. He was the one person who discarded few of the existing theories and then talked about quantum computers and then their existence. So he's a quantum physicist. Well, I'll move on to the next concept that you need to know definitely in quantum computing and that you will be learning throughout. So the three concepts that you should be aware of is superposition, entanglement, and interference. Okay. For now, just remember the names of the terms. One is quantum superposition, another is quantum entanglement, and third is quantum interference. Now, interference is one such concept that you have already studied till in class 12th. Anybody who remembers what interference is? Can you please tell me what do you understand by the term interference? Can you any example or anything? I just want to know if you guys remember or not, or you've already forgotten. Wave, okay, yes, waves. May you talk about interferences. So let's say if you have a stone and then there is a pond and you throw the stone inside that pond, you will see some waves forming in. And if you throw two stones within the pond, you'll see some waves add up, some waves, shrink down. You can observe this. This is a very simple experiment that you can do, right? Yes. So light waves, then wave optics, correct. That's the right term. Great. So we'll talk about all these three terms one by one. Okay, I'll just explain you what each term means one by one. So first of all, we'll talk about superposition. Now, I've given you the complete notes wherein you have all the technical definitions and as such, but then right now focus on the images and the explanation I'm telling you. So let's say that today you have got some superpower. Okay, imagine you have some superpower. Now, initially, when you did not have any superpower, the thing is, if you decided to travel, there's this planet Earth. You can either be present at North Pole, you can either be present at South Pole. Yes, you'll be getting this all notes. Okay, for now, just listen. So here, imagine just, you have this Earth planet, and then you decide to travel. Now, at a single point of time, you can either be present at North Pole, and let's say if you want to be present at South Pole, you can either be present at South Pole. Is it possible that you can be present at both the poles at the same time? No, it is not possible practically. But let's say if you got some superpower, like it happens in some sci-fi movies, what happens is you are, let's say, standing here, and then you have some copies, clones of you. So your clones can be present anywhere on the surface of the earth. So now you have got some 10-50 clones, and then you can again, like you can be present at the surface of the earth as well as both the poles at the same time. Now this is what superposition means. But the moment I ask you, let's say you are standing here and I ask you that what is going on at this place, the moment you decide to look what is going on at this place, all your clones, they'll vanish away and you will be only present here. Okay? Can you understand this thing? So first of all, given that we are all humans, we can either be present at one place at a time. We can either be present at North Pole, we can either be present at South Pole. But let's say if you got some superpower somehow, what can happen is you are present at North Pole and then there are certain clones of you that are present at all through the surface of the earth. But let's say if I ask you what is happening at this position, then somehow all your clones, they get vanish away and then you're just present at one single position. Now, this is the concept of superposition, and this is what we understand by measurement. The superposition is basically combination of possibilities before we measure it. So the moment I ask you to see, what if we are in middle of the, you can be present anywhere. That is what, all through the surface of the earth, these are just some clones. Any real world example? What do you mean by real world example, Shubham? You can be present at middle of the south and north pole. I just gave you north and south pole example for classical bits just to keep the explanation simple. Okay. So superposition is a mathematical concept, Shubham. So there would not be any real world example. If you were to understand that, you can understand it this way. So it is this equation that I showed you. Wait. This equation that I showed you, this is the equation of superposition. Okay, so it's a mathematical concept. Okay, great. So again, if I'm to tell you the definition, it is basically the combination of possibilities, various possibilities of where can I be present. I can be present at multiple locations. But the moment I decide to measure it, the moment I decide to look at what is happening at this part of the planet Earth, this superposition state is lost. All your clones, they are all vanished away. And then you're just present at one single location. So we either have definite answer. Will be either at 0 or will be either at 1. This is what is meant by superposition. What is meant by measurement. So superposition is same, like you're spinning the coin and then it is not even heads or tails. But the moment the coin stops spinning, you will have a definite outcome. It will either land on two heads or it will either land on two tails. It cannot happen that the coin is standing still. Is everyone clear with superposition and measurement definitions? Any doubts still here? Great. I'll move forward to the next concept, which is entanglement. Can you tell me which movie scene is this? किसी को तो याद होगा, any movie fans? Okay, great. Karan and Arjun. Great. So I'll explain you simply what entanglement is. So let's say that Karan and Arjun have got enemies. Okay. This is a very famous movie. They are the two characters, Shah Rukh Khan and Salman Khan as Karan and Arjun. So they have got enemies. Now what happens is, if or imagine that you have your twin brother or your twin sister. Okay. Now, whatever happens with Karan also happens with Arjun. So, if, let's say if Karan is having fight with some enemies, at the same time Arjun is also having fight with enemies. If Karan is going to shoot someone, Arjun is also going to shoot someone. So, if let's say you have a twin brother or a twin sister, whatever happens in your life, the same sort of things happen in their life. Just imagine it that way. So, let us take two people. So, there are two person. There is some person one. There is some person two. And then there is a secret message. I gave a secret message to person one. There is some message that I gave to person one, and then there is some secret message at person two side also. The moment person one opens the secret message, let's say this person is on planet Earth and this person is on planet Mars. Just imagine. These are two people at two different planets and they have some secret message. But the moment person one opens the secret message, we know what message is there at person two side. Though the person two is on different planet and the person two has got its own secret message. Similar to how I told you about Karan and Arjun, or how your twin brother and twin sister thing that you can imagine. So this is called as entanglement. When two qubits, this you can imagine person one as qubit one, person two as qubit two. There are two qubits at different places in the world. Two different, it can be in two different worlds, it can be at two different planets. But the moment I know the value at qubit one, I'm able to find out the value at qubit two also at the same time. So when qubit 1 is measured, it tells about something about 2 immediately. And this is one of the concepts in some sci-fi movies also. This concept is called as Einstein's spooky action. Entanglement is called as Einstein's spooky action. Can you name some movies that have demonstrated this sort of concept? This is already present in some sci-fi movies. Tenet, okay. There was Interstellar. But okay, yeah. There's some Hollywood sci-fi movies that if you'll watch, they've demonstrated this concept. So this is what entanglement means. Entanglement means when two qubits are strongly connected. The moment you measure one, you know the value at the other place. And this is something we cannot say can happen because not, we say that the thing that travels fastest is the light. But when I talk about this thing happening, it means it is something faster than light. What is the speed of the light? Light का speed कितना है? The speed at which light travels. Yes, great Lakshya. Great Atanu. Who let you know this? So this is the concept of entanglement. Is everyone clear with the concept of entanglement? No, no, that is why. This is like again, Raghav, it is for analogy, but we do not compare it with the concepts, whether it is faster than light or not. So there's some technical details to it. That is, when you study these concepts technically, you will be able to understand it. And entanglement is an idea. It doesn't exist right now. It's just an idea we are talking about. It is not proven. I hope so you got the point. It is not sending messages faster than light. It is just a concept. There is, see, this I understand that you're comparing it with the speed of travel, like let's say the light travels from sun to earth with some certain speed. But then if I talk about entanglement, it is about connection. So when you understand the nitty-gritty details of it, it is not about messages traveling. That is why we do not term it as information traveling faster than light. We just say that the information is already present at both the places. The moment at one place we are able to find out the exact information, at second place it is clear. So the analogy here mentioned is like, let's say there are two linked mystery boxes. So there's nothing actually traveling. When you open the box one, you're able to see the contents. You're aware of the box two. Yes, so they're connected. There's no travel as such. Okay. Yes, quantum level pe they're connected. Great, but good that you had these questions in your mind. Yes, so the moment we know the information at one place, we know it at second place. If we were not aware at any places, we cannot comment on it. And it can happen at either place. Cool. Are we good till here? Any further questions? Can I get a quick thumbs up from all of you? Great. We'll talk about the last simplest concept, which is interference, which you all already know. So there are two sorts of interferences that you would have already studied. Can you tell me those two types of interferences? So let's say there are two waves. Okay, let's say I've thrown stones in the pond. There are two waves. So if both the waves add up, we say it is constructive interference. If both the waves, complement each other, then we say that it is destructive interference. So this same concept is present in quantum as well. So we talk about quantum interference here. But then if I'm to understand the basic term interference, it is just quantum information, they behave like waves. So if there are two sorts of information, they just add up, they become stronger, and that is called as constructive interference. If you know if they cancel out each other, then it is called as destructive interference. For example, let's say you and your friend decided to study very hard for your examinations. Now, given that both of you are studying together, both of you will get good results, better than what you would have got individually. But if both of you decided to not study during examinations and play, then दोनों का ही result बहुत खराब आएगा. जितना खराब आ सकता था, उससे ज़्यादा खराब आएगा. I hope so this is relatable to all of you. You would have observed it. When you study with your friend, when you actually plan and study with one of your partners, it's like दोनों का result अच्छा आता है. If you both are actually studying. So this is the same thing, constructive and then destructive interference. So are we clear with the three terms, superposition, entanglement, and interference? Can you all please type these three terms in chat quickly? These are the three key terms that you need to know in the field of quantum computing, okay? Cool. So I'll move forward now. Just to summarize, that is classical computers, they use bits, quantum computers, they use qubits. Does quantum computer, if they came into existence, like right now I told you research is going on, there are a lot of certain problems that are unsolved right now. So quantum computers have a lot of errors as well. There are certain environmental conditions. Where do we need to keep it? So is it ever going to happen that your classical computers will be replaced by quantum computers? No, that is never the case. They are not going to replace it. Rather, both classical computers and quantum computers are going to work together to solve some problem. Okay, so you will be anyways. No, it cannot be upgraded as well because the entire computer is different. See, I showed you the first image. Remember here. Do you see any screen here? This is the actual quantum computer. Now, this is just some, like you have processor, right? In your devices, in your classical computers. This is the whole processing machine that you see. But do I need to, let's say if I'm doing a Google search, do I need this heavy computing thing? That is not required. So that task can already be done. It is being already done by you. So for daily tasks that you're performing, you don't need quantum computers. We need it for very heavy tasks. And that is where we will combine quantum computers along with classical computers, and we are going to have hybrid systems, both combination of them. So they are specifically designed for some highly complex problem, and they'll be used only for those purposes. They're never going to replace your classical computers for your typing work, for your whatever work you're doing till now using classical computers. They are going to be done by classical computers only. Yes. So again, I told you quantum computer. पहले तो मैंने आपको वो machine दिखाया. Now these machines are kept at very low temperatures. So there are certain environmental conditions. आपको उस room को वैसा बनाना पड़ेगा to keep that and so that they function. If we do not have those environmental conditions met, quantum systems are going to fail. If AI are trained in quantum computer, then it can be. Yes. So AI, there is something called as quantum AI, quantum machine learning, quantum deep learning, where we have combination of all the existing algorithms, and then wherever it is actually required, some quantum based ML algorithms, etc. also that we need to study, and that is where quantum and AI together can be clubbed to solve a lot of problems. Yes, you will be learning all these things. That is what your curriculum will be in future. So this is a very basic high level picture that I'm giving you about what all thing quantum computing is about. Be it cyber security being handled by quantum. Yes, so quantum computing has multiple fields within itself. So quantum computing is like an ocean. ठीक है, जैसे अब AI में भी there are multiple fields. We talk about generative AI, we talk about machine learning, we talk about natural language processing. Similarly, quantum computers may we talk about quantum uh, communication, we talk about quantum security, we talk about quantum cryptography, then there is quantum machine learning, quantum deep learning. We need to figure out where our interest lies in. We'll be learning all of them. We need to know about all of them. Okay, is this clear to everyone? Now, classical computer, of course, it is stable, mature. We are using it on everyday basis. Quantum computing is an emerging technology, and it is still developing. So, is the difference clear? Are the key terms clear? And are we good till here? And then you need to understand that no, where classical computers are being going to be replaced by quantum computers. There are two different concepts. Now, if I come to application base part, there are some examples that I've added. So I told you like discovery of new medicines. So आप लोगों ने chemistry में ये structures पढ़े होंगे, right? Let's say this is the structure of caffeine. It will have some certain atoms, some certain electrons. So you would have studied different structures. Now, when I talk about finding new medicines, तो होता क्या है अगर हम classical computers में इन structures को पढ़ते हैं, given that bits are zeros and ones, and then we are let's say talking about 24 electrons, we need to find out connections or some patterns between each one of them, and there are multiple possibilities. Let's say 2 to the power 24 possibilities are there, so it is going to take good amount of time if we are going to do that. There are a lot of unsolved problems, like let's say Alzheimer disease का कोई इलाज नहीं है, it's not curable. So Google is working on a problem called as protein unfolding, protein folding problem. So what happens is the DNA contains protein strands. They just get folded within the body, and that is when you have problems like Parkinson's, you have Alzheimer's problem. DNA सबको पता होगा, it is formed, it is the combination of four things, ATGC, right? So Google is working on protein folding problem, and they need to study all these structures. If I'm to do the same thing using quantum computer, we just need 160 qubits, and it can handle multiple states all at the same time. So to create a new medicine, we need complex molecules to understand the interaction between them, and that is possible with quantum computers. Yes, quantum computer easily password crack कर सकता है. Yes, that is the next thing, next example, which is cyber security. So right now जो मैंने आपको बताया, all the conversations that you have that happens over internet, in fact WhatsApp पे भी आपने देखा होगा, जब आप chat करते हो ऊपर लिख के आता है एक छोटा सा, all these messages are end to end encrypted. पढ़ा है सबने, ध्यान दिए? All social media applications, they mention that all your chats are end to end encrypted. It means that these companies are having access to your chats, but they do not store it. जो भी message आपने टाइप किया उसको वो किसी secret form में convert करते हैं. That is what is called as encryption. Now to conduct this encryption, ये messages को secret form में convert करना, there are certain algorithms. So there are algorithms like Caesar cipher आप पढ़ोगे in future. There is Vernem cipher you will study. There is RSA algorithms. Again, all these are technical terms. So if I'm having quantum computer has the capability to break these algorithms. They can very quickly, very, given the speed they have, they are capable of solving complex problems. So all these algorithms, RSA, it will be RSA क्या है सबसे powerful algorithm है. Until now, nobody, no human, it is based upon the concept of prime factorization. Prime factorization आपने mathematics में पढ़ा होगा. Nobody can break it. But if quantum computers come in, they can break it, and that is why we talk about something called as post-quantum cryptography. Agar quantum computers they function and they are a reality, and we have error-proof quantum computers, then we are at risks of losing everything. All the data that you have on internet can be can be accessed by people who have these systems. So all your encryptions algorithms can be broken. So we need to be prepared for it. जितना भी आपका banking transaction होता है, online banking होती है, everything that phone pay, UPI, everything that you use, they're all encrypted. Nobody gets access to your pins or OTPs or your banking passwords, etc. Is everyone, and the algorithm that is capable of doing so is the Shor's algorithm. So Shor's algorithm आप पढ़ोगे जब आप quantum computers पढ़ोगे in your second, third year. So Shor's algorithm is capable of breaking all the encryption methods. यस इंडिया ने अभी स्टैब्लिश किया नहीं है, स्टैब्लिश होने वाला है इंडिया में क्वांटम कम्युनिकेशन क्वांटम कंप्यूटर्स देन लाइक कुछ 1 किलोमीटर रेंज का एग्जिस्ट करता है बट देन अगेन इट इज ऑन वेरी अर्ली स्टेजेस इन इंडिया टू बी ऑनेस्ट only some big companies are having all these things and nothing is disclosed कि कहाँ पे कौन सा रिसर्च किस लेवल पे there's just some news that comes around but actually कितना true है that is also not known. They have just kept it all internally. Okay, so this is the second example, cybersecurity. Now, if I talk about India, India launched National Quantum Mission in the year 2023. Okay, in 2023 there was National Quantum Mission launched. Has anyone heard of this National Quantum Mission? Are you aware that there was something called as National Quantum Mission that is being launched in India? No. Cool. So what you'll do today after the session is you're going to read about it. Okay? Make sure you read about it. I'll just give you a few brief about what this National Quantum Mission is. So the thing is, India needs to, accelerate in the field of quantum computing. So the Indian government they launched National Quantum Mission, जिसका duration है 2023 से लेकर 2031 तक. And what are the goals through this National Quantum Mission? So first of all, there are 4 T hubs, thematic hubs that are being recognized. And these hubs are established at 4 places, 4 prestigious institutions, that is ISC Bangalore, IIT Madras, IIT Bombay, and IIT Delhi. So ISC Bangalore is responsible for doing research in quantum computing. IIT Madras is recognized for quantum communication, IIT Bombay for quantum sensing, and IIT Delhi for quantum materials and devices. So when I talk about quantum, what is the difference? Cores is a concept in CPU. Quantum computer may we talk about bits that are called as qubits. So you cannot relate them. Again, don't mix them. Got it? So cores is something that you have in CPU. But classical computing may you have bits. Quantum computing may you have qubits. Okay, so the first thing is there are 4 thematic hubs that are being established at these 4 big, institutions, and they are responsible for one field. They are working on some certain fields. What is the target? We need to have 52,000 physical qubit systems in India within 8 years. Right now, we have very less number of qubit systems that are actually functional. IBM ka, they give you access to the virtual quantum computer where you can experiment and then they execute it on their actual quantum computer. So again, that is what you will study in future. But the idea is we need 52,000 qubits computers within 8 years. We need to create 1 to 2 trillion economic value. That is the impact by 2035. So now you can imagine the amount of contribution in terms of money this field is going to make, and the kind of job opportunities that are going to arise in future. So 1 to 2 trillion economic value is what the government is targeting. And then there are certain, right now there are not much courses on quantum computer. Very few minor courses are available. So again, given that we need to accelerate in this field, we need more courses as well. So a lot of upskilling programs, a lot of bachelor courses, master courses in quantum computing is what the government wants to focus upon. And you guys are privileged enough to uh, have this specialization in your course, minor specialization in your course, and you'll be introduced to this already. Right now, not many people are aware of this thing. Not many people know about this subject, and there is a lot that you need to study. And given that if you study it in bachelor's, you will always have an edge. And companies are already hiring for this. So the key companies wherein there are a lot of job roles like Google, Microsoft, all these big tech companies, Amazon, IBM, they already have job openings. They already pay money, and they have already hired quantum researchers. Oracle, yes, Oracle is there. So if you search today, you will be able to find jobs in this domain. So jobs are there, but then the skilled workforce is not there. So that is what we need to create. And if in our country we need to accelerate this mission, we need to contribute. We the citizens should be aware. We cannot just export the technology from outside. Right. So here is the whole picture. Globally, what all companies are leading the quantum race? So IBM is there, Google is there, Microsoft is there. Then there are companies like IonQ, QEra. They are working on hardware part of it. Then there is D-Wave that they're again working on some certain concepts. So you don't need to understand all these terms. Just know the company names. If I talk about India, India may we have this national quantum mission where 6,000 crore rupees of uh, you know, uh, government has taken this initiative, invested 6,000 crore rupees. Then we have ISCs and IITs. NVIDIA, not sure, maybe it is there. I've mostly heard of them for GPUs. Maybe they're working on quantum. ISRO and DRDO is there. They are doing some training programs, and then they're working on quantum communications and satellites. TCS and Infosys, they are working on it. They are designing quantum software and enterprise solutions. Again, everything is in a closed environment. Some startups that I can name is QPI AI, QNU Labs, etc. Yes, so NVIDIA would also be there. I've just mentioned some global leader names. There's a lot of companies. This is not the complete list of it. Okay, this is not the complete list. There are more companies. In fact, just to name a few countries, so there is France, there is Germany, there is China. There are few more small countries that are doing much better than us right now in terms of this quantum race, and that is why this national quantum mission that is being launched is the reason that we need to accelerate here. India is a very big country that can lead in this race. So there are these are just a few companies that I've mentioned. There are many more companies. Okay. Right now, we just say that we live in NISQ era, which is noisy intermediate scale quantum. This is just a term. We are not having fully working quantum computers. There are certain error prone devices that we are happening. Okay, but this is the complete picture. Now, what you need to do is make sure that you study in which city is the quantum computer going to come, and it is going to come, I think, in September, if I'm not wrong. ठीक है सितंबर में आने वाला है इंडिया में. India has partnered, government has partnered with IBM. Then there are few more names there. You need to see it is a public-private partnership wherein we'll have a quantum computer in India soon at one of the cities. And you need to tell me what city it is. Now, what are the career paths? So first is quantum software, again, where you will be learning the coding part, algorithms, building some tools. You'll be dealing with this. Quantum hardware, this is where electronics engineer works, and they work on chips, they work on lasers. Chemical engineers work on cryogenics, and then some building these devices or the system that I showed to you. Quantum security, again, future safe encryption and then securing networks. Again, this is one of the field options for you. And quantum AI, wherein we are going to combine quantum methods with machine learning models. So these are some key broad areas that you should be aware of, and you can target any of them, whatever interests you. Hardware is what electrical and chemical engineers, electronics would probably jump in because it requires a lot of technical knowledge in terms of hardware devices there. Is everyone clear till here? यहाँ तक किसी को कोई doubts? नहीं? So just to summarize, given that I showed you the complete picture, what you need to focus on today, I'll tell you what is the difference between supercomputer, quantum computer, just to why. Just to summarize, let me finish off with this last slide. Today, given that you are in your first year, what all things you need to learn, whatever subjects that you will be taught in your first year. So you'll be taught Python for sure. You're going to learn mathematics. You need to learn linear algebra. You need to be good with the physics that you've studied. If you don't remember these quantum physics wala chapters, so make sure you revisit upon them. Or in fact, when we'll be studying about quantum, we'll be first starting with all these concepts. So the wave duality, particle, Young's wave double slit experiment, Heisenberg uncertainty principle, Schrodinger wave equation. This is all what you would be required to know. And then logic and problem solving, again, you will be learning it from the first year. So your focus right now in your first year should be mastering them. If you're good with them, when the subjects of quantum will come, you'll be able to understand them. No, supercomputer doesn't run quantum computing. See, supercomputer again are classical computers. They are based upon 0 and 1. And quantum computer and classical computers are two different kinds of computers. I hope so you understand the point. Startups are working upon like there are deep tech startups that are working upon quantum field. So there are a lot of startups that are saying that we give you quantum cryptography. So there are some certain algorithms that make your encryption better, quantum encryption algorithms that can be used. So a lot of companies are working on quantum communication, where we need to make sure how the data cables that we have, maybe they can be used for traveling qubits as well. Okay, that is how it is helping in startups. Also, is the question clear that supercomputer and quantum computer, they are two different things? Is that clear to everyone? I hope so. There is no confusion. Supercomputer are classical computers based upon 0 and 1, and quantum computer, they are not, they are no way related to each other. Okay. So, well, this was it for today's session. I just wanted to give complete picture. We talked about what quantum computers are, why do we even need them, what fields are we targeting through them, what are the key concepts, where do we stand globally, where do we stand in India, and what all things you as a student need to focus upon right now. That is going to help you in future when you will be studying about the quantum computing subjects. Okay. I hope so you have the complete picture now. Any questions, any doubts still here? Were you able to understand everything that I told you today? So make sure you do your homework, that is find out where in India first quantum computer is going to come, and then maybe post about whatever you have learned on LinkedIn. Okay, great. So thank you so much everyone for attending this session till the end, and I hope you had the best productive hour of the day. 1 hour of learning that is going to stay. Yes, it is in Andhra Pradesh, right, Keshav? Sharing my LinkedIn. Somebody asked for LinkedIn as well, so I'm just sharing my LinkedIn. Then we'll meet again, maybe some in some other session soon in campus. Yes, Amravati, right. Great, well done, Vimal. Amravati is the city wherein first quantum computer in India will be established. And the thing is, this is the quantum computer. It is very costly. Right now, only IITs have the access to, they've actually rented it in Bangalore campus. Uh, I don't know. Let's keep it as surprise. So whether Bangalore or Pune, I'll confirm it to you guys. But anyways, I'll be always there online, connected through LinkedIn, through sessions with all of you. Okay, that is for sure. Through this your 4 years of journey, you will have whenever you guys feel free to talk to me. Whenever you guys want to connect, you'll have access to me for sure. Cool. Then have a good day, everyone. Thank you so much for attending the session and keep learning. Bye. You can connect on LinkedIn. Anybody who wants to connect with me, please connect with me on LinkedIn. Great. Thank you so much, everyone. Bye. Notes will be provided to you on the dashboard. I'll inform the team, they'll share the notes with you. Okay. Okay, great. Thank you.